Recording's rolling. It is Friday, September 19th. We're going to do a couple of Kahoots today, and they just fit like pretty much exactly in the class. So we'll do one on, we'll actually start with graph translation. You guys remember like sliding graph right, left, up, down, like stretching, right? which is like last week, but it's a good review here. And then I created another Kahoot that I just pulled 3 or 4 puzzles from each of Monday, Tuesday, and Wednesday, packaged those together. So here's what next week looks like. Monday through Wednesday, we'll hit the second half of Module 2, so lessons 4, 5, and 6. Thursday will be another Alex day, and then your next quiz is Friday, so 1 week from now, Friday, and that will be on all of Module 2, which, as of now, we are halfway through. All right. Yeah, look at you guys go. You guys are hopping on Kahoot. So, yeah. All right. And then if you're not quite in yet, the pin is on the board. Here we go. Graph translations.
Where the game been? Oh, is that it?
Yeah, it's on the board right here. All right, what is the equation of this curve? Got 0, 0, 1, 1, 2, comma 4, -1, comma 1, -2, comma positive 4. Well, yeah, what's the equation of that? Y equals x squared. That's it. It's like 1 squared is 1, 2 squared is 4, and so on. Right. Makes all positive. Right. All right. So there's a vote on each of the other ones. Guys, what does y equals x looks like? What does that look like? Yeah, it's a diagonal line at 45 degrees. Right. All the y and x values match because they're the same. What does the absolute value look like? That creates a what shape?
V.
Yeah, a classic V shape. A classic V shape. Right. So 3 is 3, but the absolute value of -3 is also positive 3. Ooh, right. What about y equals 2x? Does that look like y equals x if it's twice as steep? Right? Okay, but y equals x squared, that's your classic parabola. You guys, the rest of this Kahoot is all this parabola. So this is the parent function of every single question on this Kahoot. Okay, it's just y equals x squared. All we're going to do is do some graph translation. All right, we got points on the board. We got R, Cooper, Leo, Willie, Dean. All right, going into what's the equation of this curve? That parabola shifted 2 to the right. How do you shift 2 to the right? Here, help you guys out. Didn't the point 2, 0 exist? And I think here, I'm looking at this red one. If I plug in 2, that does 0 out, doesn't it? Yeah, so that's the answer. Right. Okay. So if you do -2 inside the function, doesn't that shift it to the right too? Aha, aha. And of course, you should be able to test the point. All right, got Alyssa, R, Leo, Willie, D. What's the equation of this curve? 2 to the left. Ooh. See, I see a vertex at -2, comma 0. I see some other points too. The point 0, comma 4 exists. How do you shift 2 to the left? Oh yeah! Look at you guys go! Look at you go! Yeah. Right. So, for example, the point 0, 4 exists. Yeah, 2 squared is 4.
Yes.
The point -2, 0. Yeah, yeah. You can test out all the points too. Okay. All right, got Alyssa R on fire. Leo, Dean, Willie D. What's the equation of this curve? Here, guys, the pin's right here. You shift up 1. How do you shift up 1? Aha! Okay. So you just take the regular initial function, x squared, the parent function, x squared. You just add 1 after the fact. Yeah, that'll shift the whole thing up 1. Yeah, that'll do it. Got Katie, Alyssa, on fire. Leo, Dean, Willie D. What's the equation of this curve? Yeah. Got down 3. How do you shift down 3?
Oh, there's no.
Oh yeah, oh yeah, down 3. Right. So this red option would be left 3. This blue option would be up 3. This Gold option is right 3, and the green one is down 3. Okay. Ba-boom, ba-boom. Got Katie, Alyssa, Leo, Dean, Willie D. On this curve. Ooh. It looks like it's been stretched or squashed or something. Guys, the point 1, 4. Right. Okay, guys, there's 2 correct answers. There were 2 correct answers. Right. So, did you guys see one of the coordinates was 1, 4? Right, and the vertex was at 0, 0. So one interpretation is you could say it was stretched vertically by a factor of 4. So you just stretch the whole thing vertically by a factor of 4. Alternatively, could you say horizontally? It's sort of like it was squashed horizontally by a factor of 2, but it's like twice as skinny, sort of. Right. So the red and the blue are actually the same. Can you guys see that? If you start with the blue one and you just square that out, wouldn't this be 4 times x squared, which brings you back to the red? Okay. So both the same. Yeah. Yeah, it's right here. Right here. All right, got Katie, Alyssa, Leo, Dean, Willie G. Well, this curve. Willie G. Again, 2 correct answers. 2 correct answers. Right. So one interpretation is the whole could start from the parent function y equals x squared. You squash it down. You make it 1/4 as tall. Right. So 1/4 as a vertical squash. Right? Or alternatively, you could have said, well, it's sort of like twice as wide as a regular parabola because that's the exact same effect. So that'd be a yeah. So like 1/2, like horizontally. Right. But you guys see the red and the blue are the same thing because if you take the red one and you square it out, it does create the blue one, doesn't it? Yeah. So vertical squash of 1/4 or horizontal stretch of 2. Same thing. All right. Got R, Maxton, Leo, Dean, Willie G on fire. Equation of this curve. What's upside down? Oh yeah. Oh yeah. Just tag on a negative, flips upside down. Okay. Flips all the y values upside down. All right. All right. We're winning. Equation of this curve. Right 3 down 1. How do you go right 3 down 1? You can test it too. It's about 10 seconds. You can test. You test the vertex. Test one of those points. Ah! Look at you guys go. Yeah. So right 3. So you subtract 3 inside the parentheses. That moves it to the right. Okay. And then -1 moves it down 1 after the fact. Okay. Here, guys, wasn't the point 3, -1 one of the coordinates? Let's test that out. If I plug in 3, I should get -1 for y, right? If I plug in 3 here, yeah, this zeroes out. 0 squared is still 0. -1, that gives me the new vertex. Yeah. And that would also work for any of those other points. Was 2, 0, I think, a point? So if you plug in 2 here, this -1 squared is 1, -1 would be 0. Yeah. So all those points would work. Cooper, Maxton, Leo, Dean, Willie G, still on fire. Equation of this curve. See, left 2, down 1, and also vertically stretched. Ooh. Left 2, down 1, vertical stretch. Put it all together. There it is. Oh, look at you guys go. Yeah, there's left 2, there's down 1, and here's a vertical stretch factor of 2. It's like twice as tall as a regular parabola. Yeah. Alyssa, Cooper, Leo, Dean, Willie G. Equation of this curve. Let's see. Right 3. It's also super tall. Ooh, super tall and skinny. It's been stretched by like a vertical factor of 5, right? Oh yeah! Oh yeah! All right, 3, stretch vertically, factor of 5. That's it. All right, Alyssa, Cooper, Leo, Dean, Willie G. Equation of this curve. Oh yeah. And so looks like right 2, down 1, and then vertically stretched by a factor of 5 also. Yeah, yeah, it's all there, all there. Oh, wait, how? Okay, equation of this curve. Yeah, just a vertical stretch factor of 3, right? Okay. So actually, it did start off as y equals x squared, but everything is vertical stretch by a factor of 3. So you can do the 3 on there. All right. I got Cooper, R, Leo, Dean, Willie G. Equation of this curve. Left 2, see, upside down. Also vertically stretched by a factor of 3, it looks like. Ooh, 3 times as tall, upside down. That's it. That's it. Yeah, so there's your left 2, and there's your upside down stretched by a factor of 3. Aha, aha. Yeah. Yeah. Cooper, R, Leo, Dean on fire. Willie G. Equation of this curve. There you go. So it was right 3, up 1. It was also upside down and also stretched by a vertical factor of 3. Yeah. It's all there. All there. Cooper, Leo, R, Dean, still on fire. Willie G. Equation of this curve. There you go. All right, so right 4, up 1, and then stretch vertical factor of 3. Yeah. Boom, boom, boom. Oh, yeah. Oh, yeah. Chloe's back. Equation of this curve. Okay, left 1, up 3, upside down, stretched by a factor of vertical factor of 3. Oh yeah, oh yeah. Left 1, up 3, upside down, vertical stretch factor of 3. It's all there, all there. Cooper, Leo, R, Dean, still on fire. Willie G, still leading. Equation of this curve. Right 1, up 1, upside down. Oh yeah. Okay. So here's right 1, here's up 1, and then here's the upside down. Oh yeah. It's all there. All there. Yeah. Dean, streak of 12. Cooper, R, Leo, Willie G. Dean. Ooh.
No way, Dean just took over Willie G. There's no way.
Equation of this curve.
I don't fit for this.
Right 2, up 4, upside down. Oh, and also stretched vertically by a factor of 2, it looks like. Twice as tall. Okay, yeah, there it is. It's all there. So here's right 2, here's up 4, here's upside down, vertical stretch of 2. Ah, it's all there. We're gonna go 19 out of 20. So I think there's one more question. That's it. We're sitting on Chloe, R, Leo, Willie G, Dean, Burden. Last question for the win. For the win. For the win. For the win. What's the equation of this curve? Left 3, down 3, vertical stretch of 3. Yes, yes. It's like a regular problem would be like 1 over 1 up, but this one's like 3 up. There it is. All right. So there's your left 3, there's your down 3, and there's your vertical stretch of 3. Boom. Oh yeah. Oh yeah. All right. To the podium. With the bronze, Leo. With the silver, Willie G. And the gold, Dean. Oh yeah. Oh yeah.
Yeah.
Yeah. All right, you guys ready for the next Kahoot? Next Kahoot.
Yeah, I'm ready.
Next Kahoot.
I'm ready.
All right, so this is what we've been doing this week. Mod 2-1, 2-2, and 2-3. Here, I'll get a new pin on the board. You guys are signing up here.
And the
All right. Looks like you guys are about ready to go. The pen's still on the board. Oh, yeah. Oh, yeah. Ah, time to win. Oh, what's going on? Oh, hold on. I have to close this other one.
Yeah, whatever. I like the whole show.
Solve for
I
X.
don't know what's going on.
I'll solve it off screen. You guys solve it. If we get the same thing here.
Dude, what the sucks?
First step, can you subtract 5 over? And then you divide by 2. So x minus 3 might be positive 5 or negative 5. And then add 3 to each one. Oh, okay. That was pretty good. That's great. Right. It could have been a little longer. Right. So first thing is to subtract 5. And that brings you to this is all equals to 10. Right. Then you divide both sides by those 2. So this absolute value is equal to 5. Here's where it splits. So x minus 3 might be 5.
Yeah.
Or x minus 3 might be negative 5, right? Plus 3. Plus 3.
I didn't work it. Oh.
So x could be 8. X could be negative 2. So x could equal. And then, do you guys notice in the answer there were those curly brackets? The curly brackets means there's discrete answers. So negative 2 was an answer, 8 was an answer. Like this is, guys, is this a coordinate? No, this is not a coordinate. A coordinate would be like parentheses and x, y value. These are discrete x values that could be equations.
Are they like the X's?
Or maybe you could think of it that way. Yeah, there's a way to interpret it that way. Right here, get you going back to. All right, we got points on the board. Points on the board. Oh yeah. Oh yeah.
Oh,
You guys go.
Oh, yeah.
Solve for x. Ooh, here we go. Here we go.
Wait.
Okay, so first step, add 6. Guys, what's 15 plus 6? 21. So 3 times something equals, has to be 21, right? Then do what to both sides? Oh, yeah, divide down 3. So this bit right here must be 7, right? 7? Okay. Now, here's where it splits.
No.
So could x plus 5 itself be 7? That would be fine, right? Okay. Or, what else could x plus 5 might possibly be?
-7.
Could be -7, because that absolute value would also be 7, wouldn't it? Okay. So then subtract 2. So subtract 5 to get 2. Okay. Or subtract 5 to get -12. So x could be, and I think the answer would have curly brackets, wouldn't it? Because I'm talking about discrete answers. Could be -12, could be 2. Okay. A good thing to do too with absolute values, especially for the fancier ones, is to take whatever answers you get, plug them back to the original, make sure they work. Like if I plug in 2, 2, 5 is 7, 7 times 6, 21, minus 6 is 15. Okay. And it also works for -12. There's your answer. Ba-boom, ba-boom. Yeah, -12 and 2. There you go. There you go. All right, you guys good? I got Dean, Tanner, Chloe, Maxton, Finley. Ooh. Oh, yeah. A regulation sports ball must have a pressure of 10 pounds per square inch, plus or minus 2 pounds per square inch. How can this be represented mathematically?
I got it right.
Yeah, I do.
Yes, you said somewhere between 8 and 12 psi, right? So if you think you have the right answer, you can pick any pressure from 8 to 12 psi and make sure it checks out, right? Psi is pound per square inch. Take a pressure unit. All right, yes. Okay. So I think the way I would go about this is say the pressure could be 10 pounds per square inch plus or minus 2 pounds per square inch. Like that was given straight off the setup. Okay. Now I'll subtract over the 10 and make it the difference between the actual pressure of the ball and 10 psi could be within like 2 pounds per square inch. Okay. And then as we see the plus or minus, ooh, that sort of reminds me of how absolute values work. So if we take the absolute value of the pressure difference, it has to be less than or equal to 2 psi, right? Okay. So guys, for example, could the ball be 11 psi? 11 minus 10 is 1. 1 is less than 2. That works. Could it be 15 psi? That should not work. 15 minus 10. Yeah, okay. Could it be 9? 9 minus 10 is -1. Absolute value is +1. Okay, so that works. Okay. Could it be 7 psi? I don't think that should work. 7 minus 10 is -3. What's the absolute value of -3? 3. Is 3 less than 2? Aha. That should be the answer right there. That's the answer. So that should be anywhere from 8 to 12 psi inclusive. So it could be 8, could be 12. Kind of borderline there. Aha. Yeah, guys good? Who's winning? Shivani, Will, Dean, Chloe, Finley on fire. Equation 6x plus 3y equals 9. Put it in slope intercept form. All right, get some winners. Get some winners. So I gave you guys this formula in guys, it's not called standard form, right? 6x plus 3y equals 9. It's called standard form. Okay. So they make it. I'm trying to get y equals something. So I'll subtract off 6x from both sides. That can make it look like this, right? Look like that. And then what's the next step? Divide by 3. Okay. Next, since I have 3 terms to each get divided by 3. Yeah, over 3 over 3 over 3. Okay, that gives me y equals -2x plus 3, and that's your slope-intercept form. So these are the exact same equation. It's just two different ways to express that. Boom, 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 boom. Oh yeah. Okay. Line with slope 3 passes through the point 6,5. How can you write that in point slope? Point slope. That's what it looks like, by the way. That y minus y1 equals m times x minus x1. Okay. So y minus y1, your y1 is 5, equals m, which is 3, times x minus x1 is 6. Y minus y1 equals m times x minus x1. Yeah, that's there. There's your coordinate is 5 comma 6. Or sorry, other way around. 6 comma 5 is x1, y1, and your slope is 3. Boom. That's it. Point slope. Right? Of course you could. Okay. I got Leora, Shivani, Dean, Finley, Will. What's the slope of line through 1 comma 5 and 6 comma 25? Yeah, slope of 4. All right, so pretty good, pretty good. Okay, so this was 1 comma 5 and 6 comma 25. Okay, I don't know if my picture is exactly to scale, but that's pretty close to a representation, something like that. Okay, so if I drew a line through, I think it would look approximately pretty much like that, pretty close to. Okay, it misses the origin a little bit. Okay, so guys, this is slope rise over run. Okay, so slope is rise over run. That's like changing y over changing x. Okay. So slope is like m. I could do, okay, guys, what's 25 minus 5? 20. And then what's 6 minus 1? Okay, so that's 20 over 5, which is like 4. So the slope is equal to 4. Yeah, so if my stick figure is walking left to right, every step he walks to the right, he walks up 4 steps. So rise over run, up 4 over 1. There you go. Slope. I got Shivani, Maxton, Dean, Finley, Will on fire. Plumber works for 3 hours, charges $140 for that job. Then, same plumber works a different job for 5 hours and charges, of course, more, $180. What equation could represent how much it costs the plumber to work X number of hours? So he's going to charge some upfront fee plus an hourly charge on top of that. What's the equation? Oh, all right, getting some winners. Getting some winners. All right. Whoops. Okay. So, all right, here's what this looks like. Here's cost as a function of the number of hours worked. Right. So, C cost X number of hours, something like that. Right. So, the big picture story is that if the plumber just shows up to your door and he knocks out the job in like 10 seconds, he still charges an upfront fee. Okay. And then after that, there's an hourly rate. Okay. So we're gonna put this all together into one equation. Now, I gave you guys these points here. I said after 3 hours, the charge is $140. After 5 hours, the total charge is $180. That's what you have. So you can do one way you should solve is point slope. Can you do that? But you have to get the slope. So do you guys see the rise here? The difference is $40 for a 2-hour difference. Right. 40 over 2. That tells you the slope of this line. Which does that reduce to $20 per hour? Okay. All right, so the hourly rate is $20 per hour, but that's not charging an upfront fee. So let's do point slope right here. Here's point slope. Y minus Y1 equals M minus X one. Where the slope goes is $20 an hour, so we'll pop it in 20 right there. And then I have to pick one of these points. Let's say I pick this point here. So 3 hours corresponds to $140. Okay. And then let's see, distribute 20x, and this would be minus 60. Oh, there it is right there. Right here. And then I can add over the 40. Guys, what's negative 60 plus 140? Negative 60 plus 140 is
80.
80. Aha. Right. And that's 20x input. Right. So there you go. There's the cost equation. Right. So guys, if this plumber shows up to your door and knocks out the job in like 10 seconds, you still have to pay, how much is the upfront fee?
$80.
$80. Ah, you still getting $80 no matter what, just for showing up. Okay. And then every hour after that, you charge an additional $20 per hour. Right? That's it. And that would fit all those conditions again. All right. All right, we got Shivani, Maxton, Finley, on fire. Will, Dean. What's one solution to the system of equations? Oh, sorry. What is the solution to the system of equations? Y equals 3x plus 5, y equals 3x plus 7. Guys, those two lines are what to each other? Parallel. Are those parallel lines? Same slope, different intercept? Do parallel lines ever cross? No. Because if they cross, that's where the solution would be. But they don't cross, so there's no solution. Yeah.
So X, how you know they're
The slope, the same slope.
so like the X.
Yeah, they're both.
They were both.
Yeah, 3x. Yeah, the 3 would be the slope. Yeah. Yeah, parallel lines. There you go. All right, Maxton, Shivani, on fire. Finley, Will, Dean. Ooh, it's a tight race. Ooh. Solution to the system of equations. Y equals 5x plus 3. Y equals 3x plus 7. I would expect to work with one out on paper. Different ways to solve it. I would solve it with substitution. If you graphed it, it would be the coordinate where the two lines cross. All those answers are coordinates, right? Which is the coordinate where the lines cross. Ooh, we're gonna find out how many points we're at. Okay, so here's the system I gave you. Here's the system. Okay. Now, this is just one way to solve it. Guys, if y is equal to this and a different y is equal to this, I want to find out where they cross. Can I just set this equal to this?
Yeah.
Because it's like, why is that? Why is that? It's sort of a substitution type, right? Okay, guys, should I subtract 3x from both sides?
No.
Subtract 3x, right? At the same time, should I subtract just 3 from both sides? Right, like that? I'm trying to get all the x's together. I'm trying to get all the plain numbers together, right? So what does that give me? Is 2x is equal to 4? Is that what that leaves with? And then how do you get x? Divide down the 2? Right. So, okay, so x would be 2, right? Right. So now that's the x coordinate where the two lines are crossing. The x coordinate is 2. Okay. How do you get the y value? Can I set that 2 into either one of these x's? And of course it would give me the same thing. So here, I'll pick one of them anyway. So down here, so 3 times, now this I'll call 2, and then plus 7. Right, so 6 plus 7 plus 13. Right. So the coordinate where those two lines cross is the coordinate 2, 13. Right. That's the next y coordinate, isn't it? Okay. And so when x is 2, y is 13, that works for both equations. Ah, 5 winners. I got 5 winners. Oh yeah. I got Chloe, Shivani, Finley, Dean, Will. Oh, for the win! This is it. This is for the win. Car rental company A charges $100 up front for a rental car, plus $10 per mile driven thereafter. Car rental company B charges $200 up front, and only $5 per mile afterwards. What distance trip would result in equal expenses? Ooh. Okay, so guys, here's the system. I want the cost to be the same, so I can set these parts equal. Algebra, algebra, algebra. I'm getting x equals 20 miles out of that. By the way, if you plug in 20 miles here, 10 times 20 is 200. That'd be $300, wouldn't it? So the corresponding equal cost would happen to be $300. All right, let's see. Let's go to the podium here. We got. Oh yeah, look at you guys go! Look at you guys go! Oh yeah, the podium. With the bronze, Finley. With the silver, Dean. And the gold, yeah. Yeah. And you guys have a good weekend.